Hi, good morning everybody. We're continuing with 5.5, the triangle inequality. We'll do some exercises today. Yesterday I think we did 1 and 2 from the study guide. Let's continue with 3, 4, 5, and 6. So is it possible to form a triangle with the given side lengths? If not, explain why not. Again, the triangle inequality theorem says that if the sum of any two sides is greater than the third, then that would be a possible triangle. Okay, so let's look at number 3. Let's see the first two sides. 8 plus 8, is that greater than 8? Yes. In fact, all of them, first and third, and the second and third, greater than 8. So any two sides, their sum is greater than the third side. That means for number 3, yes, that it's possible to form a triangle with those sides. Let's try number 4. So we have 2, 4, and 5. 2 plus 4 greater than 5. 2 plus 5 greater than 4. 4 plus 5 greater than 2. They're all true. That means it is yes, we can form a triangle. Let's look at number 5. 4 plus 8, is that greater than 16? No. It's enough to say that, we cannot form a triangle. But let's just continue. 4 plus 16, is that greater than 8? Yes. 8 plus 16, is that greater than 4? Yes. But because the first two sides, their sum is not greater than 16, we can say that no, we cannot form a triangle because the sum of two sides is not greater than the third side. Now for number 6, we have 1.5, 2.5, and 3. 1.5 plus 2.5, is that greater than 3? Yes. 1.5 plus 3, is that greater than 4? Or is that greater than 2.5? That's 4.5. Yes. And then 2.5 plus 3, is that greater than 1.5? Yes. So these sides can form a triangle. Alright, pause the video and look at these questions and try to do them yourself. Alright, let's move on to a second set of questions. Find the range or the measure of the third side of a triangle given the measures of two sides. Yesterday we did number 7 and number 8. Let's do number 9 and 10. For number 9, we have two sides. The first one is 1.5 and the second one is like 5.5. So if this is 1.5, this is 5.5, then the third side would be an x. So again, according to the theorem, to the triangle inequality theorem, the sum of any two sides should be greater than the third side. So x plus 1.5, these two sides should be greater than 5.5 minus 1.5 from both sides, x greater than 4. Now x plus 5.5 greater than 1.5. That means x greater than minus 5.5 from both sides minus 4. And then 1.5 plus 5.5 greater than x. So 7 greater than x, that means x less than 7. Now the number line minus 4, 4, and 7. First one right here, x greater than 4. The second one, x greater than minus 4. And then the third one, x less than 7. Now the three solutions meet right here. That means x should be between 7 and 4. So the range for the measure of the third side is between 4 and 7. Otherwise, we will not have a triangle. Okay, pause the video and look at how we did this. Now for number 10. The two sides are 82 and 8 meters. So let's say this is 8 and this is 82. Alright, and this would be x. So x plus these two sides, x plus 8 should be greater than 82. That means x greater than 74. Minus 8 here, minus 8 here. Okay? Now x plus 82 should be greater than 8. That means x greater than minus 74. Why? Minus 82 here, minus 82 here, that would give us minus 74. And then 8 plus 82 greater than x. That means x less than 90, which is 8 plus 82. So let's assume this is minus 74, and this is 74, and this is 90. Okay? First one greater than 74, second one greater than minus 74, and then the third one less than 90. The common solution area is x between 90 and 74. So for the third side, it should be between 74 and 90 for us to have a triangle. All right. Now this lesson is easy, and we should take advantage of that. So the more exercises you do, the better. Even though most of them are simple. Let's move on to the next exercise. All right, let's look at these couple of examples. They're not that hard, but just because they have fractions, it's a good idea to revise how to deal with fractions. So we want to see if these sides form a triangle, and if not, why. Okay, so again, let's try this. 2.5 plus 1 over 1 3/4. Is that greater than 5 and 1/8? Let's convert these to improper fractions. So 2 times 2 is 4, plus 1, that's 5 over 2, plus 1 times 4 is 4 plus 3, that's 7 over 4. Is that greater than 41 over 8? We need to convert everything to same denominator, so that would be 4, 10 plus 7. Sorry, we need to make that all 8. So that would be 20 and 14 over 8. Is that greater than 41 over 8? 20 plus 14 is 34 over 8. Is that greater than 41 over 8? It's not, so we can conclude that these three sides do not form a triangle. Alright, let's move on to the next example. Alright, so for number 11, 1 and 1/5 plus 4.5, is that greater than 3/4? Again, 1 times 5 is 5 plus 1/6 over 5 plus 9 over 2. Is that greater than 15 over 4? 3 times 4 is 12 plus 3 is 15. Convert everything to the same denominator, which is 20. 20 divided by 5 is 4 times 6, 24, plus 10 times 9 is 90. Is that greater than 575 over 20? So 114 over 20 is that greater than 75 over 20? Yes. Okay. Now let's try the other sides. So 1 and 1/5 plus 3/3. Is that greater than 4.5? Okay. 6 over 5 plus 15 over 4. All right. (24) plus 75. Is that greater than 20? Okay, so 99 over 20. Is that greater than 90 over 20? Yes. Alright, now let's try the last case. 4.5 plus 3/3. Is that greater than 1.5? Now obviously 4 plus 3 is 7, greater than 1, so we don't need to continue. This is definitely true, which says that these three sides form a triangle. Alright, that's it for today. Please pause the video at any time and make sure you understand what's in it. Try doing more problems either from the book or the practice sheet that I sent you, and good luck and stay safe. Alright, see you tomorrow.